to Shop Talk with Jim and 10. This is episode 5. I'm Jim.
I'm Ken.
Hello, everyone. Thank you for joining us today. We've got two more topics to talk to you about. I'm going to talk about IP configuration management, MTU size, and default gateway. And what do you have for us, Ken?
Thanks, Jim. Today, I want to talk about the multiband radio again, sort of a popular topic, if you will. There's something unique about the way these multiband radios are built, and I've had some questions, especially for folks that are trying to order them in the store, trying to decide which ones to order. So with that, I'll pull up a document that will make this discussion a little bit easier. What you'll see if you go to our online store, if you choose the 4818, for example, that's the radio that combines 80 gigahertz and 18 gigahertz at the same time, you'll see 4 different types of terminals available, and you see these different terminal part numbers. And there's some descriptions next to them, and those are kind of important to understand. But what I want you to realize is the 18 gigahertz radio is a single band radio. That means, the high radio, low radio, they cover the entire frequency range of 18 gigahertz. And the 80 gigahertz radio is also a single band radio. You've got a high and a low. But if you think about it, when we combine these two radios together, we could have combined 2 high transmitters in one side of the link and then 2 low transmitters in the other side of the link. That would be one configuration. Another configuration would be maybe we put the high 80 and the low 18 on one side and the low 80, high 18 on the other side. That's kind of confusing, right? But it's sometimes necessary, and the reason is that the FCC is going to tell you which 18 gigahertz radio needs to go to which side of the link through FCC coordination. The high goes on side A, the low goes on side B. In most cases, you probably don't care which direction your millimeter wave radio is running. You could just choose whatever you want. But there are some conditions that if you had millimeter wave radios co-located at either one of those endpoints, you would want our millimeter wave radio aligned to the same half of the band as the transmitter of any other local millimeter wave source. Or you might have to go up on the millimeter wave licensing portal and make sure that the interference conditions are okay for a high or a low configuration. You want to do a little bit of this homework before you buy your radios. You want to get stuck with the wrong combination of radios and then causing yourself some millimeter wave interference. Millimeter wave interference is pretty unlikely, but it can happen, and especially if you're co-located. So that's really the key thing here. So what you see in the part numbers are, when you end up with this, is you've got basically an 18, what we call an 18H5. That basically means it's the high side transmitter of the 18. And this WPH, the H in that part of the model number indicates that's the high side of the 80. The matching radio for that is basically the low and the low. It's the 18L and the WPL. So those make up a matched pair. Highs on one side, lows on the other. The other two models, as you might guess, we've got the H on the high on the 18 and the low on the 80 combined in the same terminal. And then the low on the 18 and the high on the 80 combined for the opposite side of the terminal. So, those can be tricky things. Basically, you're going to install them per your 18 gigahertz licensing. And if you haven't planned ahead on the millimeter wave radio, hopefully that all works out for you. In most cases, it will. But if you are co-locating on one side or the other of the link or both sides, you do need to be very careful about which one you choose. If it doesn't matter, you just choose whichever ones we have in stock or whatever you think is going to make life easier for you. This gets more complicated with the 23 gigahertz radio because the 23 gigahertz radio has 2 subbands, a subband 1 and a subband 2. So the same things apply that I just described, except there's double the number of different combinations because we have subband 1, 23, high, low combinations. And then we have subband 2, 23, high, low, those things too. So you can see that basically just with this added digit. We have basically band 1 radio high, band 1 radio high, again with the high and the low. If you needed to match an H1 to the WPH, you'd be looking for the L1 WPH or WPL to be the opposite end. We make this easier in the store. We have an add matching radio button. So if you select one, you can just add matching radio button and you'd be selected on the opposite end. So I know that can get a little bit confusing, especially for the 23 gigahertz radio where we have more than one subband. But I want to point that out because there's a lot of part numbers you're sort of fishing and looking at those, like, what are they? Definitely that ad matching radio button in the store will help you choose the right opposite end, but you have to choose the right one to start with. So always look at your licensing, choose the right radio, especially for 23 gigahertz. And then you can either just go with what you want on the millimeter wave side or do a little bit of research and make sure that you're not co-locating at millimeter wave radio. And then if you do, you have to choose the right side. We're here to help you. So if you get confused about that and you do have a co-location, it'd probably be best to contact us, and we can help guide you to the right radio to choose.
All right. Well, thanks for sharing that with us, Ken. Yeah, it's super important to pay attention to your frequency band, your highs and lows, what you've been granted, and then making sure the right part numbers are ordered. So, like you said, we're here to help you guys. All right. Well, I've got to talk about, and it's IP configuration management, setting your default gateway, and setting the MTU size in the radio. So what I'm going to do is I'm going to toggle over to my laptop screen here, and we'll take a look at this. So I'm logged into the WTM radio. Here's our dashboard. And the first thing I want to do is come to IP management. Now, when you get a set of these radios from the factory, they're going to have some default IPs. Our default IPv4 address is 192.168.1.1. And then there's also going to be populated in here an IPv6 address, again, a default address. The problem is if you're not running IPv6 on your network, this is only partially configured. We've got the address here, but there are some more IPv6 settings you have to set through the CLI. If those aren't set properly, our next step aren't going to work right. And the next step that I want to talk about is setting the MTU size, and that's under switching and routing and interfaces. So typically my first recommendation, the first step is just come in here and delete the IPv6 address so it's blank. So you'll just delete it and press commit, it'll be gone. Once that step's done, we're going to come down to interfaces. Under the interfaces, again, there's going to be some factory default settings. And a particular one we want to change is the MTU size. So by default, the radios come from the factory at the standard Ethernet MTU size of 1548 bytes. And that's fine for passing just standard IP traffic, but anytime you're going to start running VLANs or do any sort of priority management or Q&Q, anything that's beyond a normal Ethernet packet, and it's most likely these days on most networks, you need to increase the MTU size to something larger than the default. Otherwise, the phenomenon is you'll go to log into the remote radio through the GUI or the web interface, and it won't respond. It'll sit there and wait and wait and wait. You'll be able to ping the far end. You can actually log in through the CLI, but the GUI doesn't show up, and that's because our MTU size is too small. So in my radios here, I increased them all to 2,000 byte MTU size, including my VLAN. As I had mentioned earlier, you have to delete that IPv6 address. If you forget to do that, it'll give you a warning message saying that it wasn't able to apply the MTU because the IPv6 isn't fully configured. So that's where you're going to see that. And then the other thing that's always I'm getting questions about is how do you set the default gateway? And that is done under routing and static routing. So I'll show you where that is. So to set up your default gateway, what you're going to do is for your next destination, you're going to put in 0.0.0/0, and then the next hop, this field right here is actually the default gateway field. So whatever your upstream router is on your network, you're going to put this address in here, and this will be the default gateway for the radio. So if it's not on the local subnet, this is the address it's going to send all that traffic to, and that's my next upstream router. So that's what I've got for our two little tips. Make sure you delete the IPv6 address, set the MTU size to something bigger than the default. 2,000 is usually fairly safe unless you're running jumbo frames, and you can make it. Our radios will go over 10,000 for MTU size, so whatever you need to set that for to match the rest of your network. Okay, Ken, so that's what I had for my topics. Do you have any closing thoughts for us?
No, not really, Jim. That's really useful stuff. I get, like you probably do, I get a phone call maybe once a week or more on one of those three topics. The IP6 address, the VLAN settings, or the default gateway, that last one probably being the one I hear almost every other day or something like that. So super helpful information. And yeah, you know, we try to help our customers through those problems, but it's helpful also to get ahead. So, you know, here's a nice tip for today.
Yeah, all right. Well, thanks for joining us. If you like what you see, click on the subscribe button down here, and we'll see you guys on the next edition of Shop Talk. Bye.
Take care, everybody.